All right, so you said finding the asymptotes felt a little bit confusing, so I just want to go through these rules and then the problems here for you. So when I'm finding vertical asymptotes, I know that when the denominator equals 0, so whatever polynomial is in the denominator, we're going to call that q of x. I know I have a problem when that equals 0. And so I always want to factor to see if I can find those zeros. And then I still need to know if it's not a whole. So first I want to check if whatever makes q of x equals 0, if that factor is also in the numerator, then I have a whole. And then if it's not in the numerator, then I have a vertical asymptote. So that I'm going to check that out on the vertical asymptotes. All right, and then so these are this asymptote right vertically, right up and down. And then if I'm looking at horizontal asymptotes, I need to look at the degree of the numerator. We're going to call that m. So whatever is the highest degree in the numerator, we're going to call that m, and whatever is the highest degree in the denominator, we're going to call that n. So when the degree of the numerator is less than the degree of the denominator, right? So let's say the numerator is 1 and the denominator is a degree of 2, that would be less. Then y equals 0 is my horizontal asymptote. If the degree of the numerator is greater, so say like 2 over 1, then there's no horizontal asymptote. And if they equal each other, then the leading coefficient is going to be, and we're going to see that example in just a second. So we'll start with 8. So 8, these are factored, right? X plus 1 over x minus 1, they're both factored. I can't do it. Since these do not have the same factors, I have no wholes. So I have no wholes, and then right away I can see that the vertical asymptote is what makes the denominator equal 0. So x equals 1 is my vertical asymptote. And the degree of the numerator is 1, the degree of the denominator is 1, and that's what this talks about, the leading coefficients, right? I don't have any values here, so that means they have to be 1, which means my horizontal asymptote has to be y equals 1. It's those leading coefficients, and we can see that E goes with 8. All right, I'm going to erase because I'm not going to have enough space on here. All right, so now we're looking at 9. So 9 says x plus 3 divided by x plus 3. Again, we'll start with our vertical asymptotes. It is factored, and they would cancel. So this is essentially like 1. So there are no vertical asymptotes. There is a whole at the value that they cancel, x equals negative 3. And or we see again, let's look here, we're only going to have this whole because this graph is just going to look like 1. It's just going to look like y equals 1, but x cannot equal negative 3. I would have a little hole in there. So if I was graphing this, right, here is y equals 1, here is x is negative 3, I would just have this line looking like that because it's going to cancel itself, simplify itself down. All right, so that means that f was 9. Get some space here again. Delete that out of there. Why doesn't it want to get rid of the triangle for me? There we go. All right, so number 10. Pick a different color. Number 10, we have y equals x minus 2. Well, that is factored. And the bottom shows me the factors. So again, that's my factor. Any common factor is a whole. So the whole is at x equals 2. I have one factor still in the denominator that doesn't cancel. That means that's a vertical asymptote at x equals negative 1. And the degree of my numerator is 1. Well, let's go with what it simplifies down to. The degree of my numerator is 0. The degree of my denominator is 1. So that is in the case where the numerator is less, right? This is in the case that m is less than n. So y equals 0 is going to be my horizontal asymptote. So let's see if we can find that. We have a whole at 2. So this is D. So 10 goes with D. All right, let's keep going. So number 11, pick a different color here. So number 11, sorry about the dog barking. Neighbors are out. All right, number 11, we have y equals 2x squared. And at the bottom, I can see right away that I can factor that to be x minus 4, because that would give me x squared minus 4x. All right, this simplifies down to 2x over x minus 4, right? Because this degree goes down one and I cancel that out. Right? I'm canceling this and I'm moving that one down. So we found the whole, right? First we're looking at the whole. Whole is the common factor, so x equals 0, the common factor we canceled out. Vertical asymptote, any factor we can't, so that's going to be x equals 4. And now the degree in my numerator is 1. The degree in my denominator, right, is 1 and 1. So the leading coefficients, right, that's this case again. The leading coefficients, which is 2 over 1, so just 2. Horizontal asymptote is y equals 2. So let's check. We have a whole at 0, a vertical asymptote at 4, and so C is 11. And if you wanted to stop right now and try the other two and then continue, that would be probably a pretty good idea. Get rid of those circles. Maybe pick a different color. Now, we already used that blue. Let's go with this blue. All right, so now we have 12. So y equals 1 over x plus 2 minus 3. Now this one, we could approach in a couple ways because it's not really this situation. If you remember, this one is in the situation y equals k or some value. Maybe we can use a. Some value a, x minus h plus k. Remember, this was the case where we had the basic function and we were moving it around. So this, if my vertical asymptote was at x equals 0 on the normal graph, right, this is the value moving that around. So this is going to move it 2 to the, it says minus, so remember horizontal translations are always opposite. So this means my vertical asymptote will shift to -2. And in this graph, y equals 0 was my horizontal asymptote, and this value is going to shift the graph down 3. So now instead of it being at 0, it's going to be at -3. Let's see if we have it, and we do. That's choice B. So 12, this is what I call the easy kind, because whenever we just shift it left or right or up or down, we don't even need these other rules we had at the top. Okay, last one. Let's try one more color here. Let's go with orange. Number 13. All right, so 13 says y equals x squared plus 5 divided by x minus 5. I can't factor this, so I'm done with that completely. So there's no holes because I can't common factor out anything. Means that my vertical asymptote is going to be x equals 5. And now we have a case where m, the degree of m, so is 2, the degree of n is 1. So now we have, here is this no horizontal asymptote. So this is horizontal asymptote is none. All right, and if you wanted to know kind of what this looks like at the end, whenever you have a denominator that's less in degree than the numerator, you could do the division, right? You learned how to do polynomial division. So this is going to be x times x is x squared, x times 5 is minus 5x, and then I subtract, so that cancels, that becomes plus 5x plus 5. So I have to say plus 5, 5x minus 25, and I subtract, that cancels, that becomes 30. So this means that this graph, so this part, equals, we pulled out an x plus 5, right? And then we still have plus 30 over x minus 5. And this graph is going to look like this at the ends. If you want to go and look at it on Desmos, you're going to see as it goes out to the end, the graph is going to follow that slant asymptote. And you don't have to know that quite yet, because that's what we do in advanced math too, as we look at those. But we can see that A has to be 13 because we're only looking at this vertical asymptote. So remember, there's two kinds. There's what I call, sorry about that, we will delete that. There's the easy kind, like 12, where this is telling you how the horizontal asymptote moves up and down. This is telling you how the vertical asymptote moves left and right. If it's not in that form, then you want to look for vertical asymptotes or holes, and then you want to look for horizontal asymptotes. So I hope